In this video, we will talk about how to solve right triangles. So let's work through a couple examples. Let's say we have the following right triangle, where we're told this angle is 30 degrees, this angle is a right angle, in other words, it's 90 degrees, and we don't know this angle up here in the top corner, we'll call that x, and we're told that this side is equal to 12. It has a length of 12. So to solve this right triangle, what we mean is we want to figure out what every angle is, and we want to figure out what the length of every side is. So usually the easiest way to start is if we're given two angles like this, we can find the third angle pretty easily because we know that the three angles in a triangle must add up to 180. So we can say 30 degrees plus 90 degrees plus x must add up to 180 degrees. So to solve for x, we can say 30 plus 90, that's 120, plus x is equal to 180. So to solve for x, we can subtract 120 from each side, minus 120. So we'll find that x is equal to 180 minus 120, that's 60 degrees. So we now know all of the angles. We have a 30 degrees right here, 60 degrees, and a 90 degrees right here. So now all we're missing are the two sides, this side A and side B. So how can we figure out what those are equal to? Well, we're going to have to use our trigonometric functions, so sine, cosine, and tangent. So if you'll recall this acronym, we can use SOHCAHTOA. This tells us, for example, to find the sine of an angle, we just need to take the opposite side divided by the hypotenuse. So for example, if we consider this angle 30 right here, let's say the sine of 30 degrees must be equal to the opposite side. So the opposite side is this A over here, divided by the hypotenuse. The hypotenuse is the longest side, so the 12 right here. So we can say A over 12. So we can see that we can solve for A if we just look at this equation. If we multiply both sides by 12, so if we say 12 times the sine of 30 degrees is equal to A. So we'll find that the sine of 30 degrees, this is equal to 1/2. So we end up with 12 times 1/2 is equal to A. So 12 times 1/2, that's just 6. So now we know that this side A is 6. So now that we know two sides and we have a right triangle, we can use the Pythagorean theorem to find this missing side B. So recall the Pythagorean theorem says a squared plus b squared is equal to c squared, where c is our hypotenuse. So c in this case is 12. So we can plug in the numbers that we know. So a squared, we just found a is 6. So 6 squared plus b squared must be equal to c squared. So c is 12, the hypotenuse, 12 squared. So let's see, 6 squared, that's 36, plus b squared is equal to 12 squared. 12 squared is 144. So to solve for b, we need to subtract 36 from each side. So we'll end up with b squared is equal to 144 minus 36, that's 108. And to solve for b, we just need to take the square root of each side. So b is equal to the square root of 108. If we wanted to, we could break that down into the square root of 36 and the square root of 3, since 36 times 3 is equal to 108. And simplifying, the square root of 36 is just 6. So we'll get 6 root 3. That is b. So we have now solved this right triangle. We found the missing angle was 30 degrees. We found that this side length A was 6. And we found that this side length B was 6 times the square root of 3. All right, let's try one more example. Let's say we're given this triangle where we're told one of the side lengths, so this side length is 4, and we're told this angle is 20 degrees and this is a right angle, so it's equal to 90 degrees. So let's figure out what all of the angles are and what all of the side lengths are. So once again, if we call this missing angle up here x, we know that the three angles of a triangle must add up to 180 degrees. So we can solve for x by saying 20 degrees plus, remember this square represents a right angle, so 90 degrees. So 20 degrees plus 90 degrees plus whatever x is must add up to 180. So 20 plus 90, that's 110, plus x is equal to 180. We subtract 110 from each side, we can solve for x. So x is 180 minus 110, that's 70 degrees. So this missing angle is 70 degrees right here. So now that we know all three of the angles, we can start solving for the sides. So if you'll recall our SOHCAHTOA acronym, SOHCAHTOA. If we want to find the sine of 20 degrees, we just need to do the opposite side of the triangle divided by the hypotenuse. So let's see what we get there. The sine of 20 degrees is equal to the opposite side. So the side opposite of that angle is this side all the way over here. That's 4. 4 divided by the hypotenuse, c. So we don't know the hypotenuse, so we'll just write c. So how can we solve for c now that we know all this information? Well, we can start by getting that c out of the denominator by multiplying this right-hand side and this left-hand side by c. So we can write it like this. C times sine of 20 degrees is equal to 4. And then to get c all by itself, we just need to divide both sides by the sine of 20 degrees. Divide both sides. So we'll get c is equal to 4 divided by the sine of 20 degrees. And if we punch that into a calculator, we'll get roughly 11.6959 and a bunch of other decimals after that. That's what c is. So that's the length of our hypotenuse. So now that we know the length of two of the sides of this right triangle, we can use the Pythagorean theorem to figure out the missing side, which in this case is b. So remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. So we know that a is 4, so 4 squared, plus, we don't know b yet, so we'll just write b squared is equal to, we just found c, 11.6959 squared. So we need to solve for b. So we'll get 16 plus b squared. And if we punch this 11.6959 into a calculator, we will get 136.794, roughly. So to solve for b, we need to subtract a 16 from each side, minus 16. So we'll end up with b squared is 120.794. Now if we just take the square root of each side, b is equal to the square root of 120.794, which is roughly 10.9906. So that is b. So we have solved this right triangle. We found the missing angle of 70 degrees, and we found that the missing side length of c was 11.6959, and the missing side length of b was 10.9906.